All right, what's going on, you guys? Welcome back to Prime Logic's Math Corner. Here we turn complex problems into simple solutions. Today we are diving into another fascinating Math Olympiad challenge from geometry. So get ready to decode the secrets of numbers and shapes and geometry with me. So let's get started. So as you have seen by the thumbnail now, this geometry Math Olympiad looks absolutely nasty. It is absolutely stark. There is no details whatsoever, just two sides of this triangle are given, and we are supposed to find the area of this inner square. So what is the area? So before starting solving this problem, please pause the video, think about it. As always, and as I've stated before, so the first and foremost thing in order to tackle and approach any types of problems, especially mathematics, Olympiad problems, or geometry problems, is the ability to handle and to structure and to organize your thoughts and your answers. So don't just rush into writing answers, because it just complicates and exacerbates your overall solution. So please pause the video for a second and try to find out and try to channel your thoughts. Okay, so let's get started. Here we just have two sides. So two sides of this right angle triangle are given, and we know that this is a square which is inside this big triangle here, and we are supposed to find the area of this square inside. We know that this is a right angle triangle. So this side is 5, this side. So let me name this triangle first. So let's put this vertex as A, this vertex is B, this vertex is C, and this vertex of square D, E, F, and finally G. So we know that this side is 5, this side is 12, and we are supposed to find this hypotenuse here. So the hypotenuse of this triangle, the bigger one, so which is AC, the hypotenuse is, so let's write it here at first so that we can find out this side. So AC squared equals 5 squared plus 12 squared. So AC is squared, so 5 squared, 25 plus 144, which is 25 plus 144, and it is 169. So this is AC squared is 169. So the square root of 169 is 13. So this is the length of the hypotenuse here. So let me write it down here. So we have another side now. So this side is 13, 5, 12, 13. Then let me name this side as L, for example, the side of the square. So we are supposed to find, so we should find this L side in order to find, to calculate the surface, the area of this square. We are supposed to find L at first, the side. So for example, we should now, the situation that I told you about channeling your thoughts and structuring your ideas is, so for example, we know that these triangles are similar. So if you are kind of able to find a relationship, to find a proportion between, for example, L and something else, one of these sides, and then we can solve for that and find maybe two equations with two variables, then maybe we can find L and reach to that point somehow. So, but we don't know if these triangles are similar or not, but I think we can work on this. So let's name the angles. So this big one, ABC triangle, let's name this angle as alpha. So if this is alpha and this is 90 degrees, this is beta, right? So this is just for the sake of name. So this is beta, alpha, beta, and this is 90 degrees. So based on the rules of these interior angles of any triangle, we know that alpha plus beta equals 90 degrees, right? Okay, so we know that this is 90 degrees. This is a right angle. So is this angle. So this angle is also a right angle. So if this is a right-angled triangle and this is alpha, then this angle must be beta again, because alpha plus something is 90 degrees. So alpha only plus beta is 90 degrees. Okay, great. So we know that this is a straight line. The whole thing is straight line. This is 90 degrees. So we know that beta plus something is also 90 degrees. So we know that beta plus alpha is 90 degrees. So this angle, inside angle, is alpha as well. So this is also another right angle triangle. If this is alpha, then, okay, alpha plus something, okay, you name it, is 90 degrees. So this one is beta as well. If this is beta, this is 90 degrees, then this one must also be alpha, because alpha plus beta is 90 degrees, and we know that this is also a right angle. So based on the rule of, let's say, triple angles, or let's say two angles, but here we have exact triple angles. So whenever we have all the angles of any two or other triangles the same. So if any angles, if all the angles, all the three angles of interior angles of any triangles are the same, those two triangles are similar to one another. It means that the corresponding sides, they have a similar proportion to one another. So we know that this triangle, alpha, beta, 90 degrees, alpha, beta, 90 degrees, alpha, beta, 90 degrees, and the bigger one as well, alpha, beta, 90 degrees. All these triangles are similar to one another. And the thing is, the bigger one is just magnified. It means the bigger one is magnified, and the smaller one, they are demagnified, and the bigger one can superimpose the smaller one. So we can now write some proportions here. Now that we've proved these are similar triangles. So if we name this side BG as X, let's say, and this side GC, it is 12 minus X. So let's write down some proportions here. So we divide X by its corresponding side in the bigger triangle. So in this triangle, a smaller triangle, so let me write it down here. Triangle FBG is similar to triangle, the bigger one, ABC. Thus, we can write, so the proportions, X, which is the side facing beta, and the side of the bigger triangle facing beta angle here is this one, 12. So X over 12 equals, so let's go for this side, which is the hypotenuse here. So the hypotenuse of this FBG triangle is L. So it is equal L over the hypotenuse of the biggest triangle, which is 13. In other words, we can say, so let's rewrite it in this way, X over L equals 12 over 13. So this is probably the most important thing in relationship that we wanted to reach. Now, and this makes it much easier in the next chapters and the next step. So let's write another similar proportion. So let's take this triangle into consideration. So triangle GEC, it is also similar to the bigger triangle. So triangle G, E, and C is similar to triangle ABC again. So we can write down some proportions here. So here the hypotenuse of this triangle GEC, the hypotenuse is 12 minus x. So let's write it down, 12 minus x over the hypotenuse of the bigger triangle. It is 13. So let's write it down here. Equals, let's use L again because we want to solve for L. L in this triangle is the side facing alpha. So let's equals L. And the side facing alpha in the bigger triangle is AB, which is 5 units. So L over 5. In other words, you can say 12 minus x over L equals 13 over 5. So that's another relationship that we reach. Now we can kind of simplify it and divide it here. So let me write it down here so that we can use this part. So based on this relationship, we can rewrite it in this way. So 12 over L minus x over L equals 13 over 5. So we have the value for this one, so which is 12 over 13. Let's substitute it in this way. 12 over L minus 12 over 13 equals 13 over 5. So let's solve for L now. So we can write here 12 over L equals 13 over 5 plus 12 over 13. So we can add these two fractions together. So there is no common denominator. So we will need to find the common denominator here. So 12 over L equals, so the common denominator is 65. Then, so 13 times 13 is 169 plus 5 times 12, it is 60, which is 229 over 65. So from this part, we can solve for L directly. So L equals 65 times 12 over 229. So L equals 65 times 12 over 229. So 10 times 600, 650, and then 130, so that's 780 over 229. So this is L, and the problem is solved. All we need to do is just to square this one, so which is 780 over 229, the whole thing is squared. So I want you to write down in the comment sections below, what is your method for finding this value without the calculator, because in the day of the exam or anywhere you don't, so most of the time you don't have access to calculator. So I want you to find this the number here, so based on whatever method you use, and I want you to describe it in the comment sections, how you found this one. So what is your approach for solving this, for simplifying this fraction 780 over 229, then scoring that? So what methods do you use? And after a while, after a couple of hours, I will put into the comment section the real value in the comment sections below. So I think that's it, and we solved now the area of this square here, and we had nothing at first, just two sides. We found the hypotenuse here, then we used two beautiful proportions of similar triangles, and then we solved for L, so then we could find easily the area. That was a beautiful, I think, a little challenging, but it finally it became, I think, easy. That was not like a big challenge, but that was beautiful. It looked nasty at first. So I think that's it for today. Thanks for sticking with me through this geometry adventure. In the future, we'll have grammar quiz, puzzles, and lessons as well. So if you found value in this video, please don't forget to give it a thumbs up and subscribe if you haven't already, and hit that bell icon to get notified about our next problem, our next session. I want you to share your thoughts or any questions in the comment sections below, and let's keep the math conversation going. Until next time, keep solving, keep learning, and keep your logics prime, and see you in the next video.